Hi, folks. I'm Adrian Sanabria, the host of Enterprise Security Weekly. Every week, we interview the most interesting folks we can find, talking about the most pressing cybersecurity issues and challenges facing the enterprise today. Myself and my co-hosts have each been in the industry for decades, long enough to see the patterns in the industry and explore where trends are going. In addition to enterprise challenges, we also follow the vendor space, the most interesting security startups emerging, technology and product trends, all the most interesting funding and acquisition announcements. Finally, we love to discuss the latest trends in tech and how they'll impact cybersecurity. If you're wondering how the latest in AI, quantum computing, cloud, and DevOps is going to impact security a few years down the road, you should follow the Enterprise Security Weekly podcast.
Welcome back to Application Security Weekly. We just talked with Jeff Pollard about how generative AI sneaks into enterprises, how it exacerbates problems that already exist, but also how it handles a lot of the drudgery of security processes. I'm your host, Mike Shima. I'm here with John Kinsella, and it's just about time for the news. But first, this announcement. InfoSec World 2023 is just weeks away. Have you registered to join over 2,500 security experts on September 25th through 27th at Lake Buena Vista, Florida? InfoSec World is your gateway to a world of knowledge and growth. Don't miss the chance to escape to it. I've got a cat, and that's why I'm messing things up. Don't miss the chance to enhance your career, connect with industry leaders, and make an impact on the rapidly evolving landscape. Secure your seat using code ISW23 SECWEEK20 to save 20% off your registration. Register today at securityweekly.com/InfoSecWorld2023. And clearly, check out our video feed for all the images of cats you can get. So, John... Angus aside from who's come to visit me, we do have a lot of other news in this world related to application security. One, we've got to talk about it just because it relates to our good conversation we had with Jeff. OWASP Top 10 for large language model applications just released version 1.0.1 2 days ago on the 26th. So I have a link to the PDF. I have a link to their site, which is a dedicated site as well. It's a top 10 list, though. What should we do? What's our top 10 way of approaching top 10 lists?
I don't want to be too snarky, otherwise I'd go and track down what was in the .1 update for this. Yeah, I'm sure where you are. I like the idea. I'm starting to feel that as we were talking before about, every time a new technology comes out, we create a WAF for it. And so now there's WAFs, or the equivalent of a WAF for the chat GPTs. Also, every time a new technology comes out, we have to have a top 10 for it. I mean, I guess so. I mean, that makes sense as it is. I hear myself talk. But at the same time, I don't know. Is there anything new on this? I mean, we spent an episode on this. Few episodes back.
Exactly. And I linked to that episode. So for those of you wondering why we're kind of hemming and hawing and just not really getting excited, go check out that episode. It was episode 242, if I remember correctly. So let's find something. Well, John, I don't know if this made you too excited, but there was a blog post from NCC Group Research that we're talking about the Real World Cryptography Conference. And it was a nice overview of the conference. One of the talks that jumped out to me was the titled High Assurance Go Cryptography in Practice. And the reason that it jumped out was not so much that it is about real world crypto, about Go cryptography. It was more about as they quote, the approach to creating this library is they wanted to be boring. So, and now their approach to this is secure, safe, practical, modern, in this order. But what the presentation goes into is, I think, areas that are design principles that can relate to just how do we build something securely. And memory safety is at the top of the list. That's pretty easy to say. It's just Go or use Rust. But it also mentions testing, safe APIs. It's actually talking even about code generation for drudgery or for tasks that are better done automatically than human. So this might also go back to like eBPF, things like those where you have code generation. But the last part that I wanted to highlight here was readability. And I really appreciated readability being called out as a primary motivator or a primary way of measuring that this was a call it a good library or a well-designed library. And maybe that resonates with you a bit too, because you were talking about, when we was talking with Jeff in the last segment, documentation. And so I like the idea that readable code is more secure code. I'm not sure. I'd be curious to hear your thoughts on that.
And I'm going to tie that back to, I went through this article, I missed somehow that phrase which you're using, which I just lost off my screen again, damn it. Secure, safe, practical, modern, in this order. So my thoughts there, and I get it, it makes sense, but at the same time, it's like, we're so much about, or at least I'm so much about usability and understandability and documentation, these type of things. Is practical third on my list, or would I put it a little bit higher? I mean, so I think we're sort of getting to the same point, and I think that's, I don't know, with crypto, it's as we set off air, I'm like, this is your, once I saw crypto in the title. But in a serious note, yeah, if a library is not easy to use, I don't care how secure it is, I'm not going to use it. So, and that's what the programmer had on. So that makes me concerned. And then the other thought I had here, just as you were sort of talking through that, I wonder how long until some of these more complex libraries start coming with their own GPT module. So maybe as you decide to start doing, your company decide to start supporting, I don't know, let's pick .NET for example, and like you've got maybe 3 .NET coders out of a team of 50. Do you suddenly like subscribe to the .NET module on, whatever GPT you're using or whatever module you're using, or does that come with the language or the library? I don't know. It'd be interesting to see where that goes.
It would be. And I think to your point too, especially with on the emphasis of practical, try using the OpenSSL API. It's a bit gnarly to use one loaded term that's polite. There's also, that was one of the motivators for Google to go and develop boring SSL, make things boring, because I think the synonym there is practical, to be honest, because it makes it harder. It makes it easy to use. Therefore, let's use it more easily and make mistakes harder to happen. And I think maybe that's actually the generative API aspect. It comes with the module to show me how to use this API for signing a blob, encrypting a blob. And that's the operation we want, and we want to do it maybe safe and secure, but we also want to do it in a way that's nice UX. For
what's interesting about that is, as much as we love either boring SSL or Libre SSL or any of these, I'm not seeing uptick of their use. There was a brief uptick in, well, not brief, but a relatively short uptick in Libre SSL. And I'm like, I saw some package this weekend. What was it? Might be something in the news. I forget already, but something in my passing. The author was saying, don't ask me to, port to Libre because I use OpenSSL and it's just what I'm going to do. Okay. So I think there's a lot of that out there, right? And it's like, I get it. It's a core part of your thing. You're not just going to go and rewrite it because as much as I know you love to talk about rewriting code, even like the open source maintainers aren't going to just do it because, it might be better. Those words just came out of my mouth. But seriously, right? That's, maybe that's where you use your GPT. I don't know. That's
it maybe that is, because Jeff was talking about rewriting from one language to another. Here's your blob of C into a blob of Go or Rust. But yeah, you can't rewrite easily from something that's using the OpenSSL API into the boring API. Those APIs are very different. And along that theme, I did pull in a brief article about Meta rolling out end-to-end encryption for Messenger. They're still going to do it. And this was more of a kind of an I wish reason for me to include it, in the sense that I wish, or I hope, that we'll get more of a kind of an engineering heavy postmortem on what it took to roll this out. So John maybe rightly pointed out, I do love to say, I love refactoring. Let's rewrite this code for reasons of making it more secure, more readable, etc. But if we come up with a security perspective of just apply end-to-end encryption, that's really easy to say. But look at the differences they were running into. You're talking about an architecture that switches from, handling communication messages from centralized servers, inspecting it for spam, inspecting it for abuse, inspecting it, just being able to do YouTube previews, that now you have to switch that YouTube preview generation from a centralized server onto the phone itself. And how do you do that securely, efficiently, and still preserve some of the privacy controls so you're not leaking who is generating or how that preview is being generated. So these are a lot of the subtlety that I think is hidden behind when people say, is it scalable? Because that's a little bit of my pet peeve. Like, this isn't scalable. It's kind of like saying shift left, which thankfully Jeff was made fun of that phrase a little bit too in that last
Let's
segment.
throw another overused cliche in there. I mean, literally what they just did is changing the engines on the plane while it's traveling, right? While it's flying.
There
sorry,
you go.
listeners. But yeah, it's a significant change of a product which has massive usage. It's the first thought that comes to my head is almost like going from HTTP 2 to 3, but it's even worse than that, right? It's a very significant change. So yeah, it'd be a fun. I don't think that's a single talk. I think that might be a series of talks, but I'd love to see them do that too.
Fair point. Yeah, and the reason, the reason to emphasize that engineering aspect is because I like the idea of AppSec understanding engineering, if not being a part of the engineering writing code. So speaking of planes and metaphors, is this a plane crash waiting to happen, John? Announcing Python in Excel. Now, I have some thoughts on this that I highlighted in my perhaps snarky write-up here, but I'll let you take the first stab at this.
Thanks.
You're welcome.
So, I actually did see this last week. I read a few things, but I hadn't really read the Microsoft announcement. And it's interesting to see them directly saying here that they're going to use Azure Compute, or excuse me, Microsoft Cloud. Yeah. Why don't they call it Azure? Yeah, whatever. But okay, my thought in a nutshell. Okay, neat. But let's see, where else can we do number crunching with Python? And we can do that in Jupyter Notebook. Hey, where have we seen security issues with Jupyter Notebook? Oh, Microsoft. So I'm sure they're going to learn from their mistakes and do a little bit better this time. I think it's from a pure product point of view. It's interesting that this is something that they feel. Talk about rewriting or engineering and stuff. This must have taken, I'm guessing, man years to do. So the fact that they have come out with it, that they see a significant, they must see a significant demand for it or interest in it. So I think it's going to be interesting to see what happens with it. I would be very careful about putting sensitive data into it, unfortunately. But
yeah, and you touched on those points that I was going to not necessarily make fun of, but if we just dismiss out of hand, oh, no, this isn't going to end well, I think that's ignoring the fact that a modern AppSec, modern product security needs to understand there's a business case here. And that's what you're mentioning at the end. There's lots of data analysts already doing ML in Python. Python is one of those preferred languages in that space. A lot of great data visualization that's going to come from this. So there's a lot of appealing aspects. So rather than just dismiss this and say, well, this is going to be terrible, it's more of going down the route of where your mind went. Well, let's update our threat model. Where have we seen similar failures in the past? How are they addressing this? Is it going to run in a hypervisor in the cloud? It's not going to run on the local system. The packages are going to come from a secure supply chain, so they're not going to be, at least they acknowledge the potential for malicious packages, typo squatting, that type of thing, trying to pull into this Python realm. So it's not like they were going into this blind. And I think that's just demonstrating a healthy approach to modern development. So that's my optimistic take on this today. Hopefully, I haven't broken.
I think no. I really do want our listeners to go back and, especially like the nerds, the engineers, is go back and think about why would Microsoft do this. And like the comments in here are beside a lot of rah-rah. It's a few folks saying, "Hey, we've been looking for this for a long time." So, okay, are they looking for this to do today? Are they trying to clean the data going into Excel? Are they trying to do some sort of data modeling of larger data sets? Because there for ages we've had the ability to do to plug into either SQL databases or I think to APIs also, right? But there's been a lot of ability to go out and grab data. or is this some sort of a way that they're trying to sort of getting Excel users to be able to access maybe a GPT or something like that, or more AI? Or why would you do this? I think that's worthy of our listeners spending 30 seconds thinking about where are they going with this.
I think it's just so they can get Excel to handle dates correctly, but that's just me. Let's find something, John. Speaking of large, honestly, perhaps a bit legacy software like Excel, even though it's clearly still existing and kicking, getting that Python, you've got a project from DARPA that came onto your radar. Tell us a little bit about this.
This is an interesting one. So I got one link in here to a blog post from Georgia Tech. There's a few stories out there on this. There's not a lot of deep detail on what actually is going on yet. I believe the grant has been out there and used for about, let's call it 18 months. But in a nutshell, DARPA came out and said, so for those who don't know, I think we've probably talked about before, US government is the largest software vendor in the world, like developer of software. Most number of software developers, most line of codes, like just crazy with all the stuff they've got going on. A lot of those teams ain't around no more, or the developers moved to other projects, or it's COBOL or whatever else, right? So it's like there's a lot of code which just is not being actively maintained. That code either might have security issues that they want to update, or maybe they don't have the code anymore. Maybe like either a third party wrote something and gave it to them, and the server or just the code was on that gone. Whatever it is, there's now like this binary running, and they're like, how do we secure that? Or it could be they want to move it to a more modern platform instead of being on Big Iron. They want to put it on an ARM chip, or there's all sorts of different reasons why you want to be able to get access to the source code is what we're getting at here, without either training a bunch of devs on what that source is and how it works, or just getting it. So if you got a binary, how do you update it for security is where we're going here. How do you update it for performance as your second use case? You can get something like IDA Pro and decompile it and like try to figure out what's going on and the substituted variables. And anyone who's worked with IDA Pro, you understand it. It sounds easy, just decompile, but in reality, no. When we have blog posts on here with with researchers, they've gone into IDA Pro. That's not an easy process. Okay, so what do you do? How do you do? So they've thrown 10 million to two different groups. One is a commercial org here, I think actually on the West Coast, and the other is Georgia Tech with a little more detail I went with them. But what they're doing here is this process, what they're calling distilling. So they're not trying to they're trying to decompile, but they're trying to decompile in a way that makes it usable. So it doesn't have to go down to bytecode. What they're trying to do is, can we distill a binary down into sort of objects of this, then this, then this, then this, and then have those be like certain, objects, not like an object-oriented coding, but like a thing. And then from that, can someone look at it, understand what's going on, and then say, maybe make some changes, but then have it get put back together from things into a binary in a testable, repeatable way, so that we know whatever that thing is we have, it still did what we wanted to do in that testable manner. So it's a really interesting space. As I'm talking it through, I'm like, well, do we need to do this if and I know we're talking a lot about AI as this issue and recently, but could I have a GPT or some sort of machine learning type thing sort of do some of this for me? And they're doing some machine learning in here too, but the point is sort of, again, to tickle you guys' brains. Go see what's going on at Georgia Tech. There's no demos of this out. I think they're planning on having some stuff out next year. So this is super early in this process, but it caught my interest, and hopefully it'll catch yours too.
It is really cool. And I don't have anything too insightful other than like, it'd be fun. One of the fun tests was see what can they get Doom to run on, because that's one of the classic things of getting Doom to run on all kinds of weird architectures and hardware. And the other thing here, the one thing to help our listeners perhaps, or at least as I was listening to you describe it, it sounds like, this is in a sense, I'm obviously hand waving here, LLVM turning into some intermediate representation into some IR that's turning that C code into WebAssembly, for example. That's one of the principles here. So we're going to see some large, ancient, government systems running on WebAssembly in the cloud in the future with this. Who knows? John, I had speaking of things web, and I couldn't resist just bringing in, mentioning a CVE in an OpenFire system that had a path traversal. And I don't know other than just saying, cool, I found another path traversal. It doesn't get enough respect onto top 10 lists, for example. And it's really fun to throw like %2e or %u002e, get that Unicode encoding into great fuzzers. Easy, simple, straightforward. I don't think there's anything else there, but you dove into something perhaps a little bit neater, a little bit more complicated with a BitLocker and doing some vulns there.
OpenFire I'd never heard of. So that was my learning for today on there. Beside that, I mean, the first thing that came to my mind is just like some series of like the Sun hardware used for a while was being called, there's another fire name on their clusters. But anyways, yeah, this is
showing your age, John.
One from via Hackaday, so a little more nerdy. And some folks figured out, and the reason I brought this in here, beside I keep trying to provide depth to some of these stories. So on this one, the punchline is a researcher or an engineer, I'll say, in France, realized that in Windows 11, you have to have a TPM, or you almost have to have, right? So most motherboards nowadays have a trusted compute module. One of the things which Windows is using it for is BitLocker. Their volume encryption system will go and store the key in the TPM and then bring it back and do the claimed crunchy. So the point, so I'll tell what's going through here and then why I'm bringing it to you guys to sort of think about. This individual figured out that, okay, well, if it's going between the CPU and the TPM, that means somewhere between the CPU and TPM, I should be able to read my key. If I get my key, I'm able to decrypt this volume without using BitLocker. And so they got a cheap logic analyzer. You can pick these things up on Amazon for like $20 or Baidu, or pick any of your sources out there. They're knockoffs of the real one. So if you got the caching you want to do this professionally, go get the professional one. But so you figured out on the TPM itself, he wasn't able to. Sometimes you won't be able to get your probes on there too. You won't be able to get the probes on the TPM, but what you can do is follow that back the bus on the board to figure out somewhere else is plugging into that same bus, SPI bus, and then get your leads on there. And then once you got that, you hook it up onto a logic analyzer. It becomes fairly easy to get the data coming off of it. So he did that. Then he found another website out there, which I think it's in this blog post. Well, it must be in the blog post. We're able to literally he takes a stream which he had, puts it up into a web form, and it decrypts it and basically gives him the key. So at that point, he's able to take that key. And I think he went over to a Linux box, and using that key was able to mount it. Yeah, he's using so now he's got his Windows BitLocker encrypted volume that he's able to read on a Linux box and read and write. So that's the overall the quote unquote hack. But the thought to me around this was, just because we have a TPM or just because we have something in hardware encryption, what are you doing with it? What does that mean? In a case like this, it comes down to how do you do key management, right? So if you're got a CPU as a black thing or a box, and then you got CPU in one hand, you got a TPM in the other. How do you get the key to the CPU to do that crunchy, or how do you encrypt that data or manage the encryption of that data? So you could pass everything over to the TPM and have it decrypt and encrypt, but that's going to be sort of slow, and it's going to be probably a little more brittle on the compatibility between systems. Or what they're doing in this case is at boot time, it grabs the key from the TPM and it keeps it in the memory of the CPU, which is why that key is going across that bus, which is why someone's able to capture in the middle. So, okay, do you have the key always in the CPU, or do you do what I just said before and have like that, or I think the Apple way now is they have like those are in the same die. So there's different ways you can approach this, but the question comes down to, do you need to, right? So what's the risk around that encryption key? Are you worried at home on your desktop that someone's going to come and with their probes and get the key out of your machine and start doing this? Or is it something you care about at work, or maybe you don't care about at all? So it's that thought process I thought was really interesting to think through. Just because we have hardware encryption, that doesn't mean much. How are you doing it? Do you need to do it better, or is that good enough? Like, okay, this guy figure out how to do this, but I mean, would I give this a CVE? Maybe, but it's, there's ways you could work around it. You could do, I guess you could also have like some sort of like a public key encryption going on, and actually have public private key between those two halves and have it encrypt that SPI, but then it wouldn't be SPI, or I guess it could be, but it's, I don't know. The thought experiment there to me was interesting. How do you deal with this? But also the hardware side really tickled me.
It is, and I'll let you calculate the CVSS 4.0 score for this while I add some color. So one of the aspects to this, there were two things that stood out to me as you're describing this. One is I love mentioning FIDO2, WebAuthn, et cetera. So we need those trusted anchors for the for that type of strong authentication. And that's the future of anti-phishing for most of the types of phishing attacks. So that's why I wanted to mention that. But you're also describing this, as the key is going across the bus, they want to build a metaphor of API security and security tokens. Do you have a shared secret that you're using for that API, or that's going across the wire with every request? Or you do something like an HMAC so that the secret doesn't have to go across the wire other than initial exchange, and the HMAC can be verified on each end? Or do you use public-private keys where you can generate and securely and just share that public part of the key? So I think there's some good, call it just general security lessons, or how do you approach this? You had a great summary of this as the TPM on the hardware side. I just want to kind of apply that as a API security side. So maybe these are the types of things that we try to generalize for, and the reasons why we cover lots of different aspects, because I think there's some generalization here amongst security. I don't know if you actually did generate a CVSS4 score for this, John. If you did, we can hear it now, or you can take us on to the next article.
6.9. So yeah. I think we just said something caught my interest. Hopefully it caught our users' interest too, our listeners. I think, it's there. There's anyways. We've I think beaten that horse for now. 6.9. I could probably go a little higher or lower. I'm saying that there's no availability. So if I say there's availability requirements, our availability impact then goes up to 7.3. How about that? Let's go into another story.
Yeah, exactly. Live CVSS calculations, the best kind of podcast.
That's our new podcast. Where'd our listeners go? Okay, so
exactly.
Next story. Kali Linux has a new version out, 2023.3. Yes. So we want to cover tools in here occasionally. This is a tool or a collection of tools, and I think we've covered both Kali as well as some of the other security distros in the past. What caught my interest on this one this time, I was digging a little deeper into it. They've been doing some really interesting stuff. So Kali used to be a Backtrack back in the day. This has been around for 10, 15 years now, I think.
Long time.
But so this post talks about how they're sort of maturing as an org. So there's they're improving the mirror system, better packaging tools, more automation, more repeatability, hopefully making things easier for the package maintainers. Any package maintainers out there, thank you for what you do. It's a grueling gig. But what I wanted to bring it up for is two sort of tools within the tool. One, and then maybe a second one, depending on our time here. So the first one, there's this thing just being introduced in this release called Kali Autopilot. And what that is really an automated framework for using their tools to do attacks. So I got caught trying to log into GitLab, so let me go back to our website. So attack automation framework. And this is the first release, so it's probably still a little young, but it seems pretty neat to be able to say, hey, I want to do this type of attack. And it sort of guides through the steps of step 1, step 2, step 3. And it looks like you can automate those. And this is the second, they're sort of, talk about maturity, right? They're no longer just providing tools and a really great release, but they're now actually providing tools to use those tools. The other one they had, which came out in the earlier releases here, which I'm a little bummed that I didn't notice then to talk about, is something called Kali Purple, which is really sort of what they're considering an open source version of an enterprise security suite. So they've got packet capture analysis, packet capturing, packet analysis. They've got a SIM from Elasticsearch, vuln scanners, IDSs. So they're really sort of packaging together as something that not just can be used by the white hat guys, but also this can be used in the enterprise or maybe your home lab or what have you to do purple doing defensive security, and then really autopilot doing offensive security. So I thought it was really neat to see them sort of maturing these in that different way, and it's to go and boot these up into a VM and play with them and check out some of the new stuff they're doing.
Yeah, and it is a wealth of tools in there. So there's a lot of ways you can just go on to learn different things, web, network, what have you for security testing. I will throw up a teaser. We're going to talk with Simon Bennett of Zed Attack Proxy coming up soon. So we're going to be trying to do some more in-depth discussions on tools. So listeners, if you've got other tools you'd like to hear about, let us know, because we want to make sure that we highlight the things you're interested in. John, we are getting low on time. I threw in one article, another article from Google, from the Google Cloud folks, that was about what to think about when you're thinking about securing AI. And it's not necessarily a lot of new things we haven't heard about. I don't think it is too much different, perhaps, than the LLM top 10 from OWASP in principle. But what I did like about it, the reason I highlighted it, it has a lot of similar and different to what we're already doing. And I think this was a little bit of a theme that we heard from Jeff, that AI is a big deal, but it's mostly just in marketing and demo, and it hasn't upended the industry in a realistic way. And here, again, the document goes through governance, threats, application and product security, data security, and so on. I won't list them all. But the underlying theme is that mostly it's saying that AI is complex, hard to understand, and more complex systems are harder to secure. I don't think there's anything new, not too earth-shattering. And it's talking a lot about data protection, data provenance. How are the models being trained? What have they been trained on? And can you leak data out of that? Or is that data going to be used in like a trust and safety issue? We've used the example before of, here's the model that's going to start throwing expletives when you're trying to use it for customer support, that type of thing. So I just thought it was a nice way to frame that, look at that similar and different tables. And there may be not too many things that are too different within AI to make us too worried about the future. A good sober approach, I think.
Yeah, I think the first one of the first point caught my brain, and I left it there, as AI systems are more complex. And it's we were talking about we've talked about this a lot, but like, can't see what's going on inside that box. Why does the math come to this conclusion? And then the fourth point they have on there, AI systems more interconnected. I think we're just seeing the beginning of that. So, we talk about the problem with IoT is they're connected, and that's why this, as we said before, software and plastic is firmware, and that plastic wrap is what's making those things hard to update, and it makes them easier to attack over time. I'm sure the GPTs will be updated, but still, they're saying they're not going to do too many more, is what I've seen, but 5 or 6, the connectivity is going to be live, right? So right now they're usually not going to go out and just sort of connect and do something for you per request. Imagine when that happens, and then if that's in my, I'm talking about my VS Code with AI in there, and suddenly it's able to go out and preferably just grab from a third party. But what if it starts pushing data out to a third party? So those are going to get. We're just still scratching the surface, both on the usability but also security of these things, I think.
We are. And I think we're also scratching the surface of the end of the show, which seems like a bit of a mixed metaphor. But I do want to say, listeners, I'm starting to feel like Crunchy might have to become an Application Security Weekly official slogan. So let us know in some comments if that's what you would vote on, Crunchy. So thank you, John, for that catchphrase. Thank you, everyone else, for listening. Please do subscribe, hit that like button, check out the show notes. And speaking of smart machines, check out Automatic Call featuring Lao by Nina. We'll see you next time on Application Security Weekly. Crunchy.